Hello, we are Group C. In our project, we performed object detection with YOLO V5.
What is YOLO? YOLO stands for You Only Look Once. It is an object detection framework. It is a regression-based algorithm as opposed to classification-based algorithms. YOLO V5 classifies images using a grid and predicts where to place bounding boxes.
Performance metrics. So basically the performance metrics that we used is inference time, frames per second, and power consumption. So to start off, we go over YOLO on a desktop. And the first thing to note is that the average frame per second is about 100 for the images and 125 for the camera. So about a 25 frame difference. However, the average inference time for images is a little bit higher than that of the camera. And the average power consumption for images is also a lot higher than that of the camera, with 31 watts for the images and about 12 watts for the camera.
We performed two tests when running YOLO V5 on a laptop. The two tests are process images from file and live camera feed. Process images from file is faster than the live camera feed. From the table on the right, process from file has an average FPS of 4.81, while the camera has 4.11 FPS. Process images from file does consume more power than the camera. The average power for the image test set is 16.3 watts and 14.13 watts for the camera.
On the Raspberry Pi, we tested using two configurations. We tested the inference time through a camera without cooling and with cooling. We also tested the file system. When we didn't use cooling, the performance degraded over time, and the inference time increased logarithmically. However, when we used cooling with a fan, the inference time was consistent and stabilized. A similar story is said with the power, as the power decreases over time without cooling, but it's relatively consistent when we have cooling. For the most part, the performance is unacceptable for many practical applications. When working with smaller devices, cooling is an important factor and must be considered, especially concerning the power and the stability requirements of the system. If the Raspberry Pi is to be used, the algorithm used must be less computationally intensive.
For the microcontroller section, we use an ESP32 microcontroller, and we use TensorFlow with cooling for one configuration, and for the second was with TensorFlow but without cooling. And we also used ESP and YOLO on Windows. As seen on the graph, there are many sudden spikes which are caused by the latency of the network. For ESP32 and TensorFlow, when cooling was applied, it improved the performance by 0.62 frames per second. Performance of the ESP32 and YOLO on Windows is faster compared to the use of the TensorFlow algorithm by a difference of 4.76 frames per second. As for power consumption of the ESP32, it is considered negligible. However, it increases power consumption of the Raspberry Pi from 2.7 ideally to 3.4 watts. Now let's take a look at YOLO V5 on the different devices in our demo.
Hello, we are Group C, and here is our final project for 4300. My name is Kyler Martinez.
My name is Austin Tran.
My name is Nelson Chong.
And my name is Ruben Gutierrez.
And in our project, we tested YOLO V5 across various platforms.
So the first device we tested was the desktop, and the desktop, as you can see, runs very smoothly. Compared to the other devices, this is significantly faster.
The second platform that we are running YOLO V5 is on a laptop. As you can see, compared with the desktop, it is running slower than the desktop at an average of 3 FPS.
Our next platform is the Raspberry Pi. The Raspberry Pi is a much smaller device, and as such, it runs significantly slower, taking multiple seconds to process the next frame.
In addition to running YOLO on 3 devices, we wanted to run YOLO on the microcontroller, but this wasn't possible. So we ran YOLO on the laptop, which was receiving data from the ESP32 cam and the ESP32 microcontroller. In addition to running YOLO, we went with a different algorithm, TensorFlow. Similar to YOLO, we streamed the data from the microcontroller and the ESP32 cam to the Raspberry Pi in order to process the image.
Okay, so right here we have the ESP32 cam and an ESP32 microcontroller streamed to the Raspberry Pi, and it's being displayed through this laptop.